for what's covered today. And with that, I'm going to introduce Dr. Wang and pass it over to him. Dr. Wang is the founder and CEO of Synapti Flow, where he developed a multimodal AI to accelerate medical diagnostics. He is trained as a research scientist at UCLA's Molecular Biology Institution, and he's focused on AI engineering, RAG, software development, and biomedical research under Dr. Chang. His work has expanded epidemiology, vaccines, viral mutagenesis, and diagnostics, and was complemented by earlier research at the Institute of Pasteur of Shanghai in therapeutic antibodies against H5N1 influenza. He's collaborated with Curative Inc. at UCLA, the Global Health Network, and NVIDIA in advancing AI applications in healthcare and contributing to pandemic response strategies such as COVID diagnostic kits. Dr. Wang bridges the gap between artificial intelligence and medicine with patents and findings in AI enhancement, enhanced multi-domain data analysis, saliva-based COVID ELISA tests, metagenomics for pandemic tracking, and antibody profiling technologies. He's been recognized with prestigious honors, including the NIH Microbial Pathogenesis Training Grant, the Amazon DDI Award, and the Jules Brenner Scholars Fellowship, along with nominations for the HHMI Predoctoral Fellowship and Bouquet Graduate Honor Society. His career reflects a dedication to building transformative AI-driven technologies that accelerate biomedical discovery and global health solutions. So today, this very impressive individual will be giving us a talk, so please give him your full attention and make sure that you take excellent notes. With that, Dr. Wang, whenever you're ready.
Hi, everyone. Thank you for that introduction. I should have told the AI to write something shorter. Sorry about that. Yeah, happy to be here, and glad that to be part of this talk, and of course, hopefully we can all learn something from this conversation. I want to be a bit more interactive, so feel free to interact and show what you think, and obviously we wanted to all learn something from this. Right, without further ado, let's get started. So yeah, this is my lab basically, so you can take a look. If you haven't never been to a research lab, it's the youth research lab at UCLA. We do a lot of microbiology work, including viruses and many others, bioinformatics and of course AI related research as well. But today our topic is medical AI, and yeah, so we're going to talk a lot about senses, innovations, and lots of new things, and hopefully that would broaden your perspective on how things are in today's world. So let's get started. So I've actually delved back, and I've actually graduated from a high school, and that is right here. That's not me, but this is basically where my high school is. And so, at that time, kind of thought that you can imagine that this was actually a high school, but that's where I was started my education. But eventually I was able to get into Institute Pasteur, UCL. I did lots of virology related research in Institute Pasteur, and then went to UCLA to do my PhD in molecular biology, and did my postdoc there as well. I work at NVIDIA for their AI acceleration process, graphical acceleration process, using CODA and many other new languages that are built in NVIDIA. And we're working with Apple as well on their new secretive projects on robotics. Happy to share a little bit on that secretive project as well. So yeah, so that's about it. It's the goal of this picture is to show you, hey, you never know where you're gonna get into, right? It doesn't matter where you came from. It doesn't really matter, what kind of education you've had before, as long as you are looking forward to the next big thing and be on the lookout for them. I think things will catch up and you'll be better off than, many years later, and you will look back and you cannot imagine where you have came from. So yeah, but let's go back even further more. We're going to talk a little bit about the Cambrian explosion, so which happened over 500 million years ago. And this is when a very interesting thing is that before this, the Earth was basically built with, you know, bacteria, viruses, and maybe some parasites. But ever since the Cambrian explosion, there has been a various number of species that have came about. And that is really a starting point in the sense that allowing a lot of species to evolve. And one of the key reasons that these evolve explosion have actually happened is because this is the very first time where any species actually has developed any kind of senses. So these are senses that allows them to detect the environment they're in and be more aware of whom they're facing against. And when the food chain actually started, a lot of these animals are going to have to survive. And having these sensors really help them to adapt to whichever environment they're in and allowing them to really explode themselves into different forms to survive better and adapt better. And so the same thing is happening to us. And well, yes, humans have lots of different senses to adapt and to get used to our environments. And these senses are so much greater than any of the AI that has been previously introduced. And so let's talk a little bit about AI and how that's all connected to one another. So for those of you who are in this, let's start off with some pools. Um, so what is AI? I'm sure many of you will know that, this is going to be a all of the above, but I kind of wanted to see which one do you think is the initial portion of which AI is being developed. So let's get some reactions from you guys. If you think that it's one, give me a thumbs up. I can actually see thumbs ups. Hmm.
We have 3 thumbs ups. We have 1 heart.
I have one thumbs up. Ah, so it looks like
1X.
okay. So let's okay, so I can't see all of the reactions, but okay, let's continue with that. Um yeah, so let's see if you think that it's 2 is the data, let's have a thumbs up. And if
We
you think
got
it's
5 thumbs, 6 thumbs ups.
okay, okay, and then if you think it's 3, give me a thumbs up.
We have 3 thumbs up and 1 check mark.
Okay, so yeah, it looks like everybody is pretty much think that these are all pretty much equal, but what really drives the AI in the very beginning of AI is actually the math. So here's schematics of what a neural network actually looks like. in the beginning might look very complicated, might look very puzzling, but it's really just mathematical formulas of a matrix being calculated based on the variables. So the calculation is basically an input plus the weights with the sum of them plus a variable that is being added together. So it's just basically a formula that really drives the neural network. And that is basically a layer of neural network that is being shown here, basically a single unit of it. And if you use ChatGPT or any other form of neural network, this is really the most basic fundamental of what that is. And so a lot of the progress of today's world is really based on that fundamental math that has been introduced, more than 70 to 80 years ago. So it's really just math, right? So at that time, we think maybe 50 years ago or so, nobody really cared about neural network or AI because it's really just mathematical formulas. So people don't really care about it. It didn't took off. It didn't make any kind of splash whatsoever. And then it came about image recognition. Um, it was able to recognize some of the images, given that it's a face, a face structure was shown, and it's able to recognize some of the animals. But at that time, we only had about maybe 10,000 to 100,000 images to train on. So a lot of the neural networks were not very strong to particularly analyze on exceptional details. For example, you can just look at the tail of a cat to figure out it's a cat. And it's just not enough data. And so people really didn't really care about it. It was up till,
Sorry to interrupt. I don't know if you're trying to show your presentation, but we can't see your screen.
oh, really? Oh,
Yeah,
that's too bad.
I apologize. I was trying to find a good interjection point.
Can you see now?
Yes.
Okay. Okay, let's go back quickly. Um, so, hmm, okay. So this is a schematics of the neural network. Can you see now? Yeah. If you don't, I'll just give up. Um, but basically it's a mathematical formula that is a combination of an input, weights, and variables. And there's a function to carry out various type of structure of that neural network. But this is the basics, a basic unit of neural network. Understanding that basically allows you to understand how neural network actually works, how AI actually works, and how ChatGPT actually works. But it's really just math, and nobody really cared about it. And so yeah, images are at that time were introduced, and still nobody really cared about it because it wasn't strong enough, it wasn't powerful enough. So nobody cared. It was until about the late 2010s and early 2010s where people introduced a challenge to how AIs are able to correctly recognize objects. So a lot of different groups were testing their AIs and testing their systems. And still at that time, it's very niche. It's like someone that is really into AI will only be doing something like this. It's not something that everybody is interested. So yeah, so the error rate is actually really high. This is the baseline for humans. So you can see humans are so much better in recognizing objects and things. Um, so those of you who remembers, if you go to a website which you're not, very familiar with, they sometimes test you with, hey, can you recognize 3 bridges from those 9 images, right? Most people can recognize it pretty well, and that is really used to train the Google's AI to actually recognize images better. And at that time, a lot of the AI system cannot actually do this, and they do this poorly. It was until about 2014 to 2015 where there's an exceptional increase in recognition. And that's when people really started paying attention to AI and knowing that, hey, AI may really be better than human in a lot of things in the future. And that's when people really pay attention to it. So I want you guys to take a guess in terms of what really happened in those years. Do you think that there's an improvement in computational changes? Do you think there's a data improvement? Or do you think it's a mathematical improvement? Or there's a, all of the above? So the easy answer is obviously for all of the above because everything has improved. But what do you think is the most significant improvement over those past years? For those of you who think it's number one, give me a thumbs up.
We have 16, 17,
Oh, great, great.
17 thumbs up.
Participating now. Great, 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 great. Let's see, number two, data. We have more images now.
We're at 10 thumbs up.
Okay, okay, that's a pretty good divide. How about math?
We got 2 thumbs up.
Okay. Yeah, so math is certainly not an exponential increase, right? Math has improved over the years, but it's not something that is going to have an outbreak in a particular year. Data certainly has, nowadays, even on a phone, we have probably more than 10,000 images. But really one of the major improvement is on computing power. That's when Google start developing teraflops of computational powers and really be able to train AI with millions of data. So that's really a breaking point. So most of you have probably know about AI or any kind of AI through ChatGPT and large language models. So how many of you guys have started using AI through language models?
I think, well, a couple people rose their hands in video or shook their heads, but no one's put up a thumbs up in the reaction.
Okay. Okay. That's great. Yeah. So ChatGPT is obviously an outbreak. Um, they weren't anticipating it either, that they were gonna have this type of system. It was really an internal testing um type of scenario that they wanted to release out and just to test it how it goes, and it went viral, right? But really for myself and many others, we've started really recognizing it starting from about 2015 when Google's DeepMind, if you recall, there was a time when there is a battle between the best human in Go, the game of Go, and versus the machine, and human lost eventually. And it was a breaking point in which and realizing that AI with good enough training can really beat human in almost anything. Um, so that's how AI has really came about in recent years. But what do you think really happened around 2015-ish? What made it that powerful? So we talked about computation, but what about it? What about the computation that has really led it to become powerful? Um, so I suppose there is no way. Is there any way we can let students also talk?
Yeah, any student can unmute and speak up.
Yeah, just throw it out there. Um, there's no wrong answer.
If y'all are too embarrassed to speak, we can also type in chat and I'll read it out for you. But it would be really great if we could get some students to speak.
Yeah, or else we just wait.
If I might make a guess, if it's
Okay.
okay. Could you be referring to the Transformers thing that was introduced in 2017-ish.
Yeah, I mean, the big model have certainly have been introduced, but I'm more looking for a specific mechanism that we didn't really touch upon, that really is really life-changing for a lot of these training models.
Was it GPUs?
No, it could be the GPUs. Yeah, the GPUs have certainly, increased significantly. The computing powers have increased. So let's move on to this. So what really is another really important aspect of AI is that we've reached a stage where reinforced learning has become a significant portion of training the AI models. So prior to that, reinforced learning has been somewhat there and has been improving over the years, but it has never reached to the point where there there could be introducing millions of reinforced learning, allowing that feedback loop and allowing the model to self-learn and guide itself towards the right answer. It's like almost like imagine you're playing a soccer game and you're aiming for that, you're having a penalty shot. Okay. You're aiming to go, shoot as far away from the goalkeeper as potentially possible and aiming for that very big corner at the very end of the goal. And so each time the AI is making a mistake or not being able to shoot the ball correctly, it's able to relearn itself and slowly is able to get to that very corner every single time. And so one needs to really have the power to continuously train the model to reinforce that learning process in order for the model to get good. And so therefore, with in 2015 is really when there are so much learning being processed in the Go game in order for these machine learnings to become really good at things. And so today we'll talk about a little bit more on the human health and AI for health, AI for humans, and we can discuss on how it changes and may change healthcare in general and how it may change diagnostics. So I've basically told you how how amazing we are in terms of our capabilities, how AI has taken so much time, to catch up to us, catch up to human eyes and human capabilities. We've been long able to do all of these things that AI was capable of doing. But in the same time, we also have to recognize that we as humans are also, can be problematic too. We can be biased. So if you try to read these words by the color and not by the word, if you try it, you will have a hard time, right? Not being able to read it very fluently. That's because, in your mind, it's going to appear the word and it's going to the color and the context of it will clash with one another. So you have a hard time to do this efficiently, right? So we are sometimes being fooled by our vision or our own senses. And sometimes these things are more natural and benign, but there are situations that can be detrimental, right? There are sequences where, you're in a operating room and there are potential medical errors that can be made, can lead to potential death and other outcomes. Especially so when you're in a operating room, oftentimes every single equipment and scissors or whatever, if they're missing, you have to find it. Okay. You can't just say, oh, I'm missing a pair of scissors and I'm just gonna go on with it. Because that's not how it works. You have to figure out every single item is correctly placed and they're in a correct format. Otherwise, it's going to be a problem. So with AI, it really it's going to be able to help in that direction. So then my question to you is, if we as human is biased towards certain portion of our vision, then is AI that is trained by humans are also biased? So those of you who think it's yes, give me a thumbs up.
We're at 16, 20, 21. Looks like we capped out at 21.
Okay.
Thumbs up.
That's very good. That's pretty good. So yeah, so AI is biased in certain ways. It's true because they're trained by us, and we have data that we are biased about, and therefore it doesn't really represent a fair nature of how things are. But what we typically want to try is try to make sure that AI is being used in areas that, especially for medical use, we don't want it to use it where it can generate that bias or create that bias. We try to have that validation being in the middle. And one of the things that is being tested right now is in the operating room. We can use the camera, and the camera will be and there will be an AI infrastructure being built in the camera to test for various items that are being used in the operating room. And so this is going to generate basically multiple images and allow for image recognition to really looking at different images in real time. And so therefore it's able to track all the items that are being used and not used during operation. So that is one very exciting use of AI in medical setting. And there's of course a bigger aspect of it where if you zoom out the entire hospital, right, there are obviously going to be areas where there's need for more doctors, and there are areas where there's a need for less doctors or less nurses. So being able to use AI in sort of looking at the working environment is really essential for hospital utilization of human power. Because no hospital can say we just have too many doctors, right? Every hospital is saying we have less doctors than the patient that is coming in. So they have to maximize the amount of utilization. And really, this is the only way to really help the process of moving different labors into different locations when needed. And this is another illustration of potential use of AI in medical trainings, in medical uses, that is for elderly care and home nursing. There's a lot of need for that. And our secret project with Apple is also something related to this. Not supposed to say too much about it, but really it's just going to be an iPad on the wheels that can run around. But the key is it can recognize human movement to a level where it can recognize that if an elderly is not responding, or if the elderly has fallen, these are things that it can track and recognize before it happens or while it happens, and can be very beneficial. It can also recognize your overall health. It can also recognize all of your health records, so that whenever you go to the hospital or anything like that, it can provide that to the doctors readily. So these are things that are currently developing. So let's move on to something that is pretty well established. That is AI for real imaging. So AI for imaging has been there for roughly about 10 years or so. So we're going to today talk about a very specific case of cancer, of disease diagnosis. And I want to work with you guys to potentially create a potential diagnosis that can be useful. So we hope that this would be fun and interactive for you. So before we start, quick question for everybody. can AI be better than doctors at diagnostics? Those of you who think yes, give me a thumbs up.
We have 18 thumbs up.
18 thumbs up. Oh, okay. Yeah, so the truth is not yet, right? So AI is not yet better than doctors, but in some ways or the other, it's getting so much better, right? I've recently heard that there is a rumor about opening up a AI hospital where everything is controlled by AI. Try not to go there. I think yeah, try not to get killed there. It's not a so with AI and diagnostic, we're not really there yet. There's so much more that are being recognized by human and the human doctor, but AI it's getting there. It's more like a tool for us rather than being a whole package. But there are some studies that are coming up where machine learning have outperformed doctors by 10 to 15%. But again, that is something that is really related to image recognition, which we've discussed previously that this is a 10 years old technology, has gone so much iterations. Yes, if a doctor is really tired and, you know, not in its best form, there are AI technology that can be better than them in certain type of recognition, but not all of them, because there are obviously, very borderline cases that, AI is basically not able to do, but humans are able to do so much better. But this really, gives us an indicator that maybe in the future, AI can be better than humans in very specific task of diagnosis. So today we're going to talk a little bit more about how you can help me and we can create a AI model for biological imaging, ultimately a perception of image, and finally be able to treat diseases and diagnosis. So this is a cute image of a baby. But essentially what we're trying to say is that the fetal brain development has been, very rapid over its pregnancy. Okay, so every couple of weeks, you will see a changes in the development of the fetal brain. So what we're trying to do here is we're trying to develop an AI model, try to determine if the development of the brain is in the right stage. So I wanted to, get your ideas in how we can do this, and let's work on this problem together. So basically what we're trying to do is we wanted to feed the image into the AI model, and using the images we use for training will determine the age, the timing of gestation, and of course, the images itself. And ultimately, we would test against whether or not it's going to be normal or abnormal. And then we can determine if we're doing this accurately. Okay, so since this is the premise of how this is going to go, you as a scientist, as an engineer, a software developer, what would you do first? What is the first step to train an AI model? You have one, I'm gonna just do a Google search on images that are online, and I can find millions of them. Or two, find some hospitals and actually get patient data that has matching results. Or three, ask ChatGPT to generate some photos, which is also another thing that you can do. And four, all of the above. Let's see a thumbs up for number one. Hello, hello.
I think that there was only 2 thumbs up. I was waiting
Two
for
thumbs
more.
up. Oh, okay. It's okay. Let's go for number two. Let's go to the hospital and ask for patient data.
We're at 21,
Okay, okay.
22, 23.
Okay, let's see generate images.
Six,
Oh, that's actually more than Google. Okay, how about all of above?
4, 5.
4 or 5. Okay. Oh, did you guys, some of you guys must have vote twice. Um, okay, so the obvious answer is that it's going to be number 2, which is finding patient data. Number 1 would work if we're looking for a very generic model. Say you want to train something on cats, you want to train something on generic things that anybody would have. But here we are looking for specific data because we need to make sure that this data actually fits to the overall pattern that we have, which is basically babies that are in pregnancy. So therefore, second would be good. Generative images are still its kind of infancy. Maybe in the future it can generate precise images, but at this point, it cannot really generate anything that's precisely at 34 weeks or 30 weeks. Okay, so now we have the Children's Hospital in LA, CHLA, helping us and gave us some random images. And now we try to train our AI model. Okay, we got a model. It's extremely inaccurate. So now we have 90% of errors. Okay, horrible model, right? That's basically no accuracy at all. So what do we do? What do you think is an error that we'll have? One, images are just basically incorrect. So it means that they give us images that are, we don't have to look at these images. These are just placeholders. But what do you think is biggest reason that would lead to this inaccuracy? That is, images are incorrect, images are not labeled correctly, and images are not formatted correctly. For number 1, thumbs up.
Not seeing any thumbs up.
Oh, okay. Number 2, thumbs up.
We got 6, 7, 10, 15, 17.
Oh, wow. It's like a
We got that.
so it's like growing, and it's like everybody want to go on the train. Okay, number 3.
We're at 10. Looks like we capped at 10.
Okay, okay. Sounds good. So yeah, so most likely I think the issue is with 2 and 3, right? So one of the things that we wanted to make sure we do with any image we use for training is that we want to make sure that they have the image and they have the corresponding number of gestation. So the pregnancy weeks or the patient's, general data, right? Because this allows for a more of a context for the AI to learn about it. If you just give the images without any context or without any label, then there's no way of AI actually knowing how to correctly classify this image, and therefore you will get a less accurate data. And what I mean by formatting is that when we actually upload these images into the cloud or into TensorFlow or whatever training software that we use, what we basically are doing is trying to format the images to a good proportion, whereby the resolution and the size of the image are reasonably the same. Otherwise, the training again will be all over the place. So it's always nice to obtain raw images. In this case, it's called DICOM images from the hospital directly, and then process those images using specific softwares and systems before being uploaded for training purposes. So let's assume the number 2 and number 3 are the ones that we have we have done. And here you have an AI model, right? But now it's about 50% accurate. Okay, so that's unfortunate, because it's basically, again, a toy cost, right? It says 50%. So what's now the issue is that you've only trained with a little bit of data. Maybe you just got it from one hospital, and one hospital have only maybe a few hundreds of data, or maybe 1,000 data or more. So now you need to amplify the amount of data. Now, what is the option that would be best for amplifying the training? Number one, you want to continue working with a few hospitals and say, I want just high quality data. But number two is I want high quantity of data, but not necessarily high quality. Which one do you think is most important at this point? Number one or number two? For number one, let's have a thumbs up.
We are at 12, 15, 18, 19. Looks like we capped at 19.
Okay. How about number two? Quantity.
We got 11. I think we capped at 11.
Okay. Okay. It's a good spread. Yeah, I think so. So these two are both valid way of training, amplifying the training, for an AI model. But particularly for a hospitalized setting, you probably want to go for number one, that is the high quality. Because again, high quality models will often give you a much higher quality results at the end of the day. Your accuracy would significantly be improved if you go with number one. If you go with number two, you might see various potential, possibilities, but then the training is not exactly weighted towards that specific need you will have. So again, number two is more for something that is less specific. Let's say if you are interested in finding all sorts of cancers, then having number two is probably better than number one. But in this case, we're doing something very, very specific. So now you've improved the accuracy, but unfortunately, your model is still having about 40% of errors. So do you want to give up? Probably not, because we still have about 5 minutes left in this conversation. We have to get things done. So now you realize that there's another issue with this um, AI model, that because you're dealing with baby and fetus and the development of the fetus, you're actually noticing that a lot of the images are not actually focused on the brain, and that these images can also include the body parts of the mom and the fetus outside of the fetus. And so a lot of the images are not properly trained because of the fact that there are lots of variables outside of the brain. And because every time you take a CT scan or X-ray or anything like that, you cannot say, hey, a little kid, can you stand in a position or sit in a position that is the same, and no, then that's not going to happen. So that's going to be a problem, because every single position that is introduced is one extra variable that AI has to take into consideration. And if it's not knowing exactly where the brain is, it's going to be a problem. So now, how do you solve this problem of telling the AI where the brain is and not the rest of the body? Okay, so this is actually a pretty complicated question, and I'll help you a little bit on that. And the way to do that is to introduce a second model. And the second model basically is going to be a second convolutional neural network that recognizes only the brain, only the area outside of the brain. So you recognize all your body parts of the mom, of the pregnancy, outside of the brain, and it recognizes that, and then feeds that information to the second layer, which then localizes into the brain. So, and then it goes to another neural network, basically, using different layers and filters to really figure out how is the brain going to be differed from image to image. So this is a smart way of how AI models are built. So remember, we talked about how a unit of AI models in the very beginning of the talk, but these are always stacked against one another to create even more complex systems, ultimately allow you to solve a more complex problem that seemingly very simple, but it's really very complicated. So in this scenario, a two model system is used side by side in order for you to actually determine the final results. So finally, we have an AI model that is, well, still have a little bit of accuracy errors and about 15% accurate. But this is good. This is a very good step, which means that it's about 85% accuracy for most of the tasks that it's able to do, and it's able to do the job pretty well. Yeah, so that's kind of really it. The future of AI, there are lots of new things that are being done. What we've discussed on are just very surface level of what we have been working on. In today's world, there's a lot more. Clip is something that is introduced by ChatGPT, or OpenAI system that allows for both text encoders and image encoders to work hand in hand into one another to form this matrix so that the images are able to translate to text and text can generate images and vice versa. And this is something that I know you've been using, and Google is trying to do the same thing as well with something called Nano Banana. I don't know if you guys have tried it. It's actually really cool. But this is all something that has been in the process of development, and many of them have already been doing pretty well. So in the future, you don't even have these images. You may have these images and tell exactly with the AI will actually tell the doctors, hey, this is the image of the brain and this brain has these issues. It would be able to contextualize everything. And not only that, we have foundational models in the future that is able to do more than just one thing, but maybe a model that can recognize skin cancers, recognize brain, and maybe also recognize some tissues and the cells and various things they can do in one go. So this multimodal kind of system is going to be the way for the future, and yeah. So in the future, we think that AIs will be able to work with other AIs and work with different doctors and nurses and ultimately be able to better take care of all the patients in the world. Yeah, and I think it's going to be a crazy 10 years of lifetime for everyone. So that's it. That's the talk, and I hope you guys enjoyed it. Yeah. Thank you so much for your time.
I have a question.
No one has. Oh, great. Thank you, Samantha. Go ahead.
I was wondering, are there any so far really negative aspects of AI that have been noticed, especially in the medical field?
Yeah, there's a lot of negatives. I don't know. It's just there's with anything there's if there's anything positive, there's anything negative, right? I would say the most problematic portion of AI is the fact that it has it's a little bit delusional, right? It will create things out of the blue. Sometimes you give it some data and then let it do some analysis, and it will just create some data on its own. So it's kind of a problem that everyone is trying to solve as well. Um, so in terms of algorithmic levels, yeah, that is what it is. It is a generational model, and so therefore it's going to generate things that are maybe incorrect, and oftentimes, if you do searches online, you might see the similar kind of issues. They would create something, it would say something that may not exist, but it would just say it because that's how it works. On economy level, it might means that in the future there will be less people, less jobs. But I don't want to get there. You guys are, it's gonna be like a few years ahead of you guys.
If I might ask, that was a great presentation, Dr. Wang. I'd love to hear like how you got into the AI field and maybe like what sort of work you guys do at your lab, since I know it combines AI and some other fields as well.
Yeah, so we got into AI because of because it was more of accidental. We initially work on viruses and epidemiology. But you know, with viruses, it's kind of a slippery slope in the way that once you start working on viruses, you begin to work with the evolution of virus, and you begin to work with epidemiology data, which is always big data sets, and these are kind of pushing you into doing something that is more machine learning than or bioinformatics than just lab work. And so that's how we get into it. In terms of what work we're doing a lot of work with radiologists here at UCLA. We provide analysis for patient data, and especially when it comes to um, patients that are positive for their cancer treatments. So essentially, what happens is if you're positive on cancer, you basically need to take a CT scan or MRI scan on a daily basis, and that gives a lot of work to doctors who has to look through all the images and scans to figure out if the treatment was successful or the treatment wasn't exactly doing its job. So these are things that we do. In addition to that, we also do some more of a um, research oriented things, like for example we can do a automated AI system which allows for automatic analysis of clinical samples, and as well as datas, and um, create data sets for easy access to viral samples or many other things. So yeah, there's just a lot of things we can do with AI. If you guys want to play around with AI, there's a lot of options as well. A lot of people do vibe coding. There's Hugging Face. There's a lot of AI codes in there that you can play around with. As long as it's not too intensive, most of the computers can run them, and you can train your own system. Just play around with it. Yeah, it's great.
That's super cool. Thank you.
Excuse me, I had a question. When it came towards the different projects that you guys did, how did you decide whether or not to use a simple model or like a deeper and more thought out like neural network for the AI that you used and you trained?
Yeah, of course. So that's a good question. That's a good question because um with 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 the development of AI nowadays, there are so many models to choose from, and so many options. Initially, we wanted to use a more of a convolutional neural network model for image analysis, and convolutional neural networks has been, recognized more than 10 years ago, and it's been sort of in the forefront of image recognition and for CT scans, MRIs, and anything in between that. But the problem with that is, again, it's also limited by its simplicity, that only recognize images and does not provide context to the images itself. And it's also limited by the number of images being used to train it. So we are more at this point using transformer models instead. So like the clip where we can use transformer models with potential diagnostics to that model, so that when the patient comes in, they do the analysis, they do the scan, immediately you're not only getting the results from the image, but you're also getting the context from the image as well. So they would tell you exactly where the size of the tumor, and then of course, and give a diagnostic to the doctor, and doctor would determine whether or not you need to come back, or you need to stay for a little bit longer, or you need to do a reanalysis. So it really comes down to the utility of it. I think if you want something very specific, say you're just interested in lung cancer and you just wanted to look for lung cancer, then a convolutional or something simple, a simple model would do. But then if you're looking for something a bit more broader and have more context and have a bigger model, then transformer model would be good.
Great. Someone asked in chat, how does radiology utilize AI?
Yeah. So radiologists are probably the first group of people that uses AI, if at all, because for them, a lot of the work is really on imaging, and imaging, AI recognition in imaging has been the most well established, right? So what happens exactly in the situation is that when you're given the image of the brain, for example, that we talked about today, AI is able to recognize the different departments of the brain and actually provide a label to those departments. And then it's able to recognize where the particular cancer is going to be and label that cancer. And so in that sense, you're able to provide a radiation treatment to that particular location. And of course, there's something called the cone beam CT. Cone beam CT is a special version of CT that is particular to a very small area. Cone beam CT is typically used during the operation of radiation. And so basically what it does is it can recognize the exact location of that tumor and actually send the accelerator to target that tumor. We're working with UCLA again with radiation centers to target specific tumors with a proton. So this allows the tumor to break without actually affecting other organs or the brain or any other organs, so that you have a safer treatment without having all of these problems with chemo and all those craziness during cancer treatments.
This is kind of like a broad question about like AI and like how it's like kind of shaped medicine. Do you think like because like AI has become so popularized within like the past few years, do you think it's like truly helped to like improve patient diagnosis, or like is it just like a we see more people using it so like it seems better kind of thing?
So with hospitals and doctors, they're obviously not like trend followers. Like they don't care, to be honest with you. They don't care if AI is good enough or not. They probably don't care if your AI is not reaching like 99% accuracy. So with hospitals, they are very, very um, conservative when it comes to AI. And obviously, it's very different from day-to-day use, like writing emails. Diagnostics are very complex and sometimes require multiple doctors to work together as a panel in order to even determine the results of that diagnosis. And that's for good reason, right? The precaution of the, I mean, the overall results can be very dramatic if you have a different type of treatments being recommended. So therefore, hospitals are very, very cautious about using AI. They're definitely not going to use it until becomes really, really good. A lot of AIs are FDA approved for diagnostic purposes, but still, hospitals are very cautious to it. They don't want to really use it unless it's going to help them significantly. So right now, what the hospitals are actually doing is that they basically use AI for a data consolidation or data summary type of thing. They're not going to use it for your diagnosis or anybody else's diagnosis at this point, just because they don't dare to do that.
Great. Thank you so much. Any last questions before we move on to Cray's talk?
I do have a follow-up question and kind of adding on to what you were saying before, Dr. Wang, if no one else has any questions.
Yeah.
So I just wanted to start by adding on to what you were just saying. I do see the same thing that I think in healthcare, there's always like a little bit of a time gap to adopt new systems. I think it's kind of just because if you have a system that's working for sure, you should prioritize that over like adopting a new system until you know 100%, because it's depending, like human lives are depending on it. So I think that is kind of the trend, but I think it's good to have people that push for the new systems. For example, with AI, just to keep everyone moving forward. But in my like shadowing in hospitals, I've also only really seen AI used like for maybe summarizing like notes that doctors are taking, like on the medical records, maybe like as like a assistant to like a scribe or something, maybe if the everything that they've written down, maybe just to dumb it down to a little bit like a more cleaner format. That's the only case that I've seen. And I've also seen like some doctors that maybe have reached out or like used a diagnostic AI, but just for like a very light consulting, but not used it really in their decision process, just like for kind of context. But yeah, I do see the same thing. I did want to ask you though, like obviously with the AI field like being so emergent and tied to all these different fields, it's kind of a follow-up to my earlier question, but how would you recommend like students who want to get into this field since it's so multidisciplinary? How would you recommend like going about maybe if they want to be in medicine but still within AI, since there's only a lot of times it's only really like a one specific path, either like down medicine or down technology. There's obviously a lot more overlap now, but do you have any recommendations?
I don't know. It's career choices. It's very individualized. It's hard to say, right? Because like with coding and software engineering, um, it might be harder, right? As AIs are better at coding. So a lot of people are saying that, obviously AI can be better and better at coding softwares. So I don't know. I think this is something that is a personal choice, but I don't think it if you are doing coding and you wanted to be a software engineer, there's no reason why you can't do it for the medical use. I know a lot of software engineer would do it for biotech companies, they would do it for medical companies. I don't see why you have to be a doctor in the same time. In the same breath, if you are a doctor and you want to focus on AI and you want to focus on software, you can do that too. You have the ability to know exactly what you need and try to create systems that would, help to reduce the pain that you have currently in your current job. And so therefore there's also a need for that. So I think, down the road it's, yeah, it is come down to the individual. If you think that, you are interested in both AI and medical side of things, you just have to, ask yourself which one you want to do it for the rest of your life. And there's no wrong answers to that.
Thank you.
Alrighty. With that, I think the questions have stopped. Cray, do you feel like you have enough time to give at least some of your talk?
Yeah, I think I think Dr. Wang gave a really good comprehensive intro to like AI and stuff. And I don't want to like overlap with my presentation. So I can talk, I think, about my experience, and I think it would be really helpful. And then maybe leave open for questions, since I know last time there were a good amount of questions about just general college stuff as well. So I'm happy to contribute like that.
Yeah. Okay, great. I want to pull up bio, but my internet is not working great. But to all of our students, Cray is a current UCI student. I don't know exactly what his major is in, he can say that himself, but he actually took MIRE as a high school student and found it very valuable, and he can impart some of his knowledge onto all of you. Cray, you can go ahead and introduce yourself. I'm so sorry.
Thank you for the intro. I will share my screen really quick. So I did have this little bit of a longer presentation, but I'm just gonna dumb it down, I think, to let me go full screen here. So I to give a quick intro, I am a entering fourth year undergraduate student at UCI. I'm a biosci major specializing in genetics. And I have a health informatics minor on the side. And I'm a pre-med student, but over my past couple of years in my undergrad, I've realized that although I'm very passionate about pre-med and going into the biology and medical field, I also have a big interest in like technology in general, as well as like informatics and a little bit of like it branches over into the AI and technology stuff that like we talked about today as well. So I sort of decided I wanted to continue my pre-med journey, but also try as much as I can to branch out and be a little bit more multidisciplinary as I go down my career journey. So I think I can give a quick overview of like my journey in MedTech and AI, as well as just overall college experience. And then I can open it up to questions if you guys have about this, or even just general college questions, since I know there's always a lot of stuff to think about when going in from high school to college. So yeah. Um, so just a quick intro. When I joined my undergrad, in my first year, I assumed I was gonna just do straight pre-med, go straight to med school. And the thing was, it was sort of a convenient decision that I made when I went into my undergrad, as like both my parents were doctors, and I liked my biology classes in high school. And because of that, I was like, oh, I think I would be a good fit in medicine. Then going into my undergrad, taking some of the classes, I had this realization, and this is a realization that most college students have. And you will probably go through it too, because a lot of college students will typically kind of see how it is, maybe change their major, change or refocus their things. So I had that same kind of path where I realized I hadn't put as much thought as I should have into why I wanted to go into medicine and what I was aiming for at the end goal. Um, so after a little bit after like a year or so, I realized okay, I need to stop for a second and think about why I want to go into medicine. And I need to think about, okay, is there anything else that I really do also feel passionate about that maybe I could either consider pivoting to or trying to combine it with health. So one thing that stuck throughout since like elementary and middle school was it was just sort of a hobby, was graphic design. And when I got to high school, I did a couple of like advanced graphic design classes and I got a lot into it, and I was pretty passionate about it, but it was just sort of like a side hobby thing. And then when I joined UCI, during like the first club fair or so, I went straight to look for the design club. So I joined that group, and that ended up being less of a graphic design sort of club and more of a UI UX design. And I can get into more of what that is, but it's not as relevant. But I realized that through that community um, that I had this interest for not necessarily graphic design on its own, but sort of like the design thinking process and how it relates with like technology and how people use their devices and how to design like applications and websites around how people use things and how humans interact with computers. And that's sort of what UI UX is. That's sort of like a quick definition. So I realized I had this like big interest in this as well. Um, so around that same time, I was thinking, okay, like I need to reframe, I need to figure out, okay, what do I really want to do? Um, and I had the chance to intern at the Children's Hospital of Orange County. That's just over here, like over up in Orange, just like 15 minutes away. And that was a summer program where we interned at the hospital and we had the opportunity to shadow like almost every single specialty of doctor within the hospital. So we shadowed through like radiology, neurology, thoracic surgeons, um, almost all the specialties. We even had some time in the operating room. And through that, as well as the fact that in this internship, they really pushed for pre-med students to be more open-minded to thinking about how medicine interacts with technology and innovation and stuff like that. They really pushed for that in that internship, and it really sort of opened my eyes and sort of gave me the comfort and encouragement that I needed to sort of double down. So through my shadowing experience there, I realized that like the health system is like so much larger than I initially thought. So there's obviously like the actual providers, the doctors, and their clinical rotations that they do. So everything you might know as on a surface level, but there is so much to the healthcare field in terms of how there are entire industries and fields dedicated to building technology to help within the hospital and in patient care settings. And there are connections with from healthcare all the way to like even law or like community stuff like public health, all that stuff, even to design, there's a lot of connections. So when I realized that, I realized, okay, there is an option for me to explore and find sort of the niche that I think I would be the most effective in with my interests and my skill set. And so that sort of encouraged me to look more into that. And that started me on this journey of trying to look for more um, of bridging the gap between healthcare and technology, whether that's like AI or like data science, stuff like that. Um, Let me see how we're doing on time. But after that, I went on to look for a bit more multidisciplinary opportunities. So I had the opportunity to attend a global summit conference for AI in medicine, and that was in Orlando, Florida. So we flew across the country in like a group of people from our internship, and I had the opportunity to present like an abstract for just an idea of how of a product that utilizes AI that could help solve some issue in healthcare. And there I had the chance to meet a lot of people who were in that multidisciplinary role. Okay, they were either from the healthcare side, so like they were doctors in the past, but then they were pushed by someone, or they just sort of happened upon AI or just technology in general, and then they tried to push and bridge the gap to the other side, as well as a lot of people coming from the computer science or the technology side, trying to bridge the gap into healthcare. So meeting a lot of those people was really inspiring, and it was really kind of like a guiding experience. And then since then, I've been just trying to build my repertoire on both sides. So this past summer, I had the opportunity to intern at a health center here in SoCal. It's called Camino Health Center, and they have three major clinics, one in Lake Forest, one in San Juan Capistrano, one in San Clemente. And there I was able to do a lot of work for like their data science side. I was able to kind of work with their electronic health records and to like work with managing their data as well as building a dashboard for them that sort of reports visually um, what's data that they're working with their patients so that they can sort of see what gaps there are in their patients and kind of address it. And that had sort of like a design aspect to it as well. So it was a really nice roundabout journey there. So that's sort of my journey up till now. My plan in the future is to continue down the pre-med journey. I'm planning to apply for med school this next year. And my plan is to keep doing that as a baseline, and then on the side, continue to explore these interests of technology and medicine, see how they can, combine into health so that we can, help build our future, I guess. So yeah, that kind of gives a little bit of an overview. I hope I wasn't um too long with it, but I'd love to open it up to just any general questions. If you guys have questions on this stuff or any questions on college experience, stuff like that. I did this is my fourth year, so I'm going out of it now, but I've gone through the whole process. So if you have any questions about that, feel free. So I'd like to open up to questions.
As before, you can type your questions in chat or say it out loud.
Hi, I have a question.
Yes.
So my question is, do you think AI is going to be more beneficial or negative? And if so, how do you know it's going to help us more than hurt us? Like, how are we supposed to trust AI?
Yeah, that's a good question. I think that's really like kind of the heart of the whole thing with AI. I personally think that as long as we develop this field, as with any other like technological advancement in the past, as long as we develop it with the proper like regulation and care to make sure that we're still prioritizing people and we're making sure we root out all bias, any sort of like misdiagnosis, opportunity like that. I think that this, like the AI advancements, is just another advancement, just like any other technological advancement that we've had. And similarly, like I think when you're working day to day and you're using AI, I feel like there's both a good, like healthy way to use it and like an unhealthy way to use it. So like if you're using AI like while you're working and you're sort of help asking it just for like help with ideation or helping like flesh out an idea that you already have, um, or sort of like um, helping like structure something, but you're still making that ultimate decision or that thought process is still yours. It's no different than like just asking a mentor or making a quick Google search. It's just a bit more tailored to that. So, but if in contrast, if you're working on something and you're using the AI to just do all the decision making, and with like almost no input from you, then that's a very unhealthy use of it. And it first of all, will likely not get you that far just because the answer that AI will give is always going to be just kind of an average of all the data that's been fed into it. So it won't be a very productive answer. But secondly, it's only if you really use it as just a really powerful tool that I think it's going to be the most productive.
One student messaged me directly and asked, are there any specific experiences that you had in high school that pushed your ambition in pre-med and AI tech? Is being spread out in pathway slash career concepts such as data science and UX design with healthcare and medicine beneficial? I think the question is like, having this diverse skill set, is it beneficial? And what made you want to go that way?
Yeah. So, my thought process in high school going into undergrad was more just about generally what did I want to go into. So I knew I always had like a little bit of interest in technology. Um, but I figured I really liked my biology classes and I liked learning about like how, for example, with cells, all the different processes, like you have all the different like protein receptor chains, you have the DNA to RNA to protein process. The way all that works together, I liked thinking about it, like the way it all kind of works together to make a functioning cell. So that's sort of why honestly, it was that like conceptual kind of thing that I liked, that made me go into pre-med. Um, and I guess what my journey now in college, once after I've had a lot more of this reflection about why I want to go into medicine, is sort of rediscovering that and like rediscovering what really drives me and what drives me to be passionate in like what I'm doing. So it's easy to be like, um, I can do pre-med and I can go into medicine or go into research because it'll be good for me and like it'll lead me to like a good position at the end of the day. And that's definitely like part of the reason, but I think you can only really I guess how do I word it? You can only really push yourself to be that level of successful if you know why you're doing it and you sort of like play to your own strengths of like, okay, this I like this aspect of it, so this is why I want to do it. And that kind of um ties into why I've been trying to expand these into these other fields. Because like similarly to how I liked learning about how the cell, all the different processes of the cell worked, I'm realizing I have a similar interest in learning how the healthcare system works because there's so many different aspects of the healthcare system outside of like the providers, outside the doctors, the nurses. There's also all the people that work on like medical technology. There's the people that work with the electronic health records, managing the data. There's people that work with like on the law and regulation side, making sure things are up to standard, figuring out like the best ways to do things. There's so many different moving parts. And I'm realizing that that's learning about that is something that really drives me personally. So that's kind of why I've been trying to kind of open my mind more to all these different fields and see where I maybe would personally fit in. Because I think the one stigma that I had with the healthcare field that made me hesitate for a little bit in the first couple of years was like it's such a big commitment. I'm signing up for 4 years of medical school and then another 2 or 3 years of residency. Like it's a 8 year almost commitment. And it's easy to think of it as like, oh, what if I'm not like, or what if I don't succeed? Like, what if I am not able to handle all of the stuff that I have to learn and memorize? Um, it's easy to kind of fall into that, but then after realizing that like there's so many different aspects of the healthcare system, I realized there is a place for almost like every single personality and like every single person has like an area that they can kind of, even if there isn't a niche, you can kind of force yourself into that niche. So that really encouraged me. Yeah. I do see a question in chat. Do you think that AI is taking over med field jobs or tech jobs? Short answer, yes, but I do think at the same time that it's opening up higher positions. Now, I think I can't really speak on like how it'll be because I don't know like how stuff has changed in the past that much. But honestly, whenever there are like new advancements in any field, obviously the people that those new advancements, the stuff that those tools can now do instead of a human, obviously those jobs are taken away because the machines can do them. But I think at the same time, it allows people to then use those tools as a stepping stone. So it's like instead of say you're writing an essay, so instead of and yeah, say you're writing an essay and you only have a certain amount of time, and maybe without using AI, you have to think about, okay, how am I going to word my points? Like, how am I going to write everything? Like, what words am I going to use? Like, specifically, like, how am I going to outline it? Stuff like that. Um, and you might have less time to think about what you actually want to say and like what points you want to make and more about actually writing it. But then if you use AI it to help you like maybe create an outline or like you have an idea of what you want to say, but you want just a bit of help like fleshing it out without having to sit for a couple hours to flesh it out yourself. it lets you then think about the deeper part of it, which is like what the actual point is. So it kind of gives you that stepping stool. So I think similarly, AI, although it will go for those bottom roles first, I think it then allows people more time and energy to um, move a little more advanced. So I don't know how like I don't know if the rate will be the same. Like maybe there'll be more jobs taken away than more new jobs than are created. So I can't really speak on that, but I do think that is kind of how it is.
I got another direct message that asked, would you say that shadowing has helped you decide that you want to pursue a career in medicine and or a specific specialty? Do you know of any ways high schoolers can get shadowing experience?
Yeah, so Um, I would say the shadowing experience that I had definitely helped me. So like I said before, I sort of thought of medicine as like a kind of looming thing, being like, okay, it's like years of commitment, and then I'll eventually, like a decade later, get into a doctor position. So I thought of it as like kind of like that. But then when I shadowed, I realized I just didn't really have context to what I was working towards on a pre-med track. So like when you're doing the pre-med classes in a university, they're teaching you the basic information that you need to then be able to understand the concepts that you'll be working with in a doctor job or in a medical job. But those classes themselves are not giving you context onto what the actual job will be like in its day to day, or like what the work life will be like an actual idea of the job itself. You don't get that from classes alone. So I think it's honestly very necessary to do like some sort of shadowing, or you can also look into like getting a clinical, what's it called, like a clinical experience or like a patient experience job. So there's options like medical assistants, EMTs, as well as like I think the nurse, I forget what there's like clinical assistant, stuff like that. You can search up like patient experience jobs. You can, there's even like scribing, stuff like that. Any sort of experience that lets you get a glimpse at the patient workflow, meaning like seeing the patient come in to see the doctor, everything that they have to go through before they see the doctor, and then when they do see the doctor, there are a lot of like jobs that let you do that. And that is kind of the thing that medical schools will look for as one of the requirements is like, do you have a patient experience? Do you have a couple hundred hours of like working in a patient experience role, whether that's shadowing or like a job? So I guess that's how I recommend looking into it. But I definitely think it helped me get a much clearer idea of, okay, this is like the job that I'm working towards. And now I can actually see myself working in this position. So I have a reason to actually work towards it for like a couple of years in medical school and then residency. I know what I'm working towards. So it definitely helped me.
I had a question. So, kind of adding on to that, what are some tips to getting an internship or shadowing opportunity? Because I know it's like harder for high school students to get yours in high school.
Yeah, so personally I didn't get mine in high school, and that's part of the reason I think that I had that sort of hesitation when I got into my undergrad. There are a couple of options that I could say now retroactively. This program that I did with Children's Hospital of Orange County, it was really good. It was mostly student led on one half, and then the other half was like the shadowing and like all the providers from the Chalk Hospital came to talk and give their sort of advice and experience on their career journey, stuff like that. This program accepted both undergraduate students and high school students. I think there were some uh, the issue is just that with high school students, it's harder to get like the regulations sorted through just to allow people like to work in like a patient experience job. There are a lot of opportunities. It's just like you have to be a bit more selective with it, or like you have to be a bit more careful, like looking into it, because it's usually hard. But this program did allow high schoolers to shadow at least a little bit, not as much as the undergrads, I think. But yeah, I would recommend, honestly, the easiest way, I think, is through direct like connection that you might have. And it's hard to just have that. So I would maybe recommend like if you have a local clinic or something, or if you know of any providers, I would recommend maybe like cold emailing a bunch of people and asking them if they might be open to it or if they have any recommendations um for getting involved. So like because even if like you're not gonna get a full job, you might have some opportunity to shadow. Yeah.
Hi, I just wanted to add on to that really quick, especially if you're with College and Career Advantage. We have so many different programs built into our education system that we have the dental assisting, medical assisting, the medical internship class, where all of the sports medicine course as well. We have all of these different pathways that you can complete with internship experience. So you can still kind of get a filler to decide if you're interested or not. The medical internship class is really great because you rotate through different departments of the hospital. And once you complete one CCA class, then you can go ahead and do that. So if you have more questions on that specifically, just reach out to me and you can talk more. Thank you.
Thank you. Another student asked, for people who are exceptional in math, which medical field would you recommend that would not only benefit hospitals, but also the individual as well?
Ooh, that's a tough question. So, um, I would say I don't personally have enough knowledge of like the day-to-day of every single specialty to say like which would be the best like definitively. But if you're coming from math, and it depends on like what you mean by coming from math, like as if you want to continue doing math in the medical specialty, or if you want like the medical specialty that be more the most fit for you because you like math. Um, I think it really depends. I think there's a lot of opportunity. There's honestly a space for every single niche, but you just have to really like find it. Um, and I will say like if you're coming from math and you sort of like math because it's like really like logical, and it's about like, solving problems, then there are specialties that maybe lean more towards that, but honestly, the patient workflow itself, with like from a doctor's perspective, for example, is they are going to be seeing a patient and then having the patient, describe to them what symptoms they're having. And from that information, they'll have to make a sort of judgment on, okay, this all out of all these possibilities and this information that I have from the patient, what do I think the most likely issue would be, and how can I try to address it, or how can I test to see if it's what I think it is. So there's a lot of logic there. I will say some specialties maybe have more of that than others. For example, I think when I was shadowing, I saw that stuff like neurology, or like radiology, stuff like that, they had more, um, I guess they had more time to think in their decision making because I guess for with radiology, you're analyzing images for the most part. With neurology, it's like those conditions are a lot of the conditions they deal with require more of like in-depth thinking of what might be like the psychological cause or stuff or whatever of that condition. And a lot of times they're not as urgent to be dealt with as something like a cardiac problem, or something like that. So with some specialties, it's more about the urgency and doing stuff like surgeries or doing treatments quickly, but still precisely. And then other specialties, it's more about like, okay, it's not an urgent thing, but I want to figure out what the problem is and what the root cause is, so I have to think more in depth. So there is like a differentiation like that, but I will also say there are almost definitely ways that you can be multidisciplinary within any field. Whether that's like finding a position that sort of splits your time between like medical stuff and maybe like more of a research side. There's a lot of people, there's a lot of doctors that will do like clinical rotations and then do research on the side. That could be an option. Um, or maybe there is a field that sort of combines the two. There's a lot of options like that. You could also go into medical technology, like kind of like the engineering side. I know it's not math, but it does have a lot of math within it. So there's a lot of options like that. It's just about kind of exploring what you're wanting out of it and what options there are now.
Alrighty, thank you so much. With that, we are at the end of our time for this class. I really appreciate and want to extend a great thank you to Cray and Dr. Wang. Your presentations were very insightful, and I know all of our students appreciate your time. With that, if you still have questions for Dr. Wang or Cray, you can message me on the portal and I can send a group email. I know Cray had put his LinkedIn account, so you could connect with him and ask your questions.